Good morning to all of you. This is Muva Prasad signing into DCEB Suryapeta on live streaming classes. Almost all we comes to an end in the online classes. We are in the first topic, real numbers. Introduction is completed by Prasad. Has already medium and medium statistics, and also we are going to continue with the reviewing part of yesterday's previous class, which is really real numbers. You can be ready with your pen and go through the ask the
Sir, please give screen share option.
okay.
Seen, sir.
సార్ ఏందో మొత్తం వస్తుంది.
Okay. Good morning, all of you. So, New Year wishes to one and all. So, this is Ashok. So, it is our second class in first unit, real numbers. So, first class in the new year also. So, today we will continue the topics from real numbers. So, I have given an homework to you from exercise 1.1. So, in that, this fifth question is a bit of tough. So, I start from this problem. Look at fifth problem in exercise 1.1. Look at here. Show that one and only 1 out of n plus 2 or n plus 4 is divisible by 3, where n is any positive integer. Means out of all the 3 occasions, n or n plus 2 or n plus 4, out of all these, only 1 is divisible by 3. So actually, what is n? N is any positive integer. So we have to prove out of all these 3 conditions, the only 1 is divisible by 3. So already we learned division algorithm, and we did some few sums. I am taking a positive integer is a, and I am assuming b is 3. So by division algorithm, what is the formula? A is equals b into q plus r. Here the condition of r is 0 less than or equal to r less than b. Okay. So just we have taken for a equal to n and b equal to 3. So substitute these values here. So that becomes, in place of a, we have written n, in place of b, simply put 3. N equal to 3q plus r. Here 0 less than or equal to r less than 3. Okay, children, you have to observe cleanly and note it in your notes. So I will give time, and after this you have to solve the remaining sums whatever you have in the textbook. Then only you can get easily. So now So we know if you are dividing any number with 3, the possible remainders are 0, 1, 2. Means if you are dividing with 3, the remainder may be 0 or 1 or 2. Okay. Now, what are the possible conditions? Look at here. N means, so okay. N is equal to 3q and N is equal to 3q plus 1. Means I have substituted for r is equal to 0, we get N equal to 3q. For r is equal to 1, 3q plus 1. For r is equal to 2, N value will be 3q plus 2. So, N is equal to 3q, N is equal to 3q plus 1, N is equal to 3q plus 2. So, you have to show for N, out of all these, the only one will be divisible by 3. Okay. N is equal to 3q, N is equal to 3q plus 1, N is equal to 3q plus 2. So, for this, first condition N, 3q or 3q plus 1 or 3q plus 2. Out of all three situations, only one will be divisible by 3. So let us see. So the first case is I am taking for n equal to 3q. Okay. So clearly n is equal to 3q means 3 multiple. So it is divisible by 3. Okay. What is the next condition? N plus 2. First of all, we take n value, n plus 2 and n plus 3. Out of all these three conditions, the only one will be divisible by 3. Here, I have taken n is equal to 3q. So clearly it is 3 multiple, so it is divisible by 3. Next, n plus 2 means add plus 2 to this 3q. So it becomes 3q plus 2. Okay. According to the division algorithm, here the remainder is 2. Means it is not divisible by 3. Okay. Next, why it is not divisible by 3? In 3q plus 2, 2 is the remainder. Okay. So, next n plus 4, take this condition. N value is 3q. We are adding 4 to the n value, that becomes 3q plus 4. Here I am rewriting 4 as 3 plus 1. From these two, I am taking 3 common out. So 3 into q plus 1 plus 1. Okay. Here also the remainder is 1. Means it is not divisible by 3. So what happened here? N plus 2, n plus 4. Out of all these three situations, the only one is divisible by 3. Remaining n plus 2, n plus 4 not divisible by 3. Okay, are you getting? Now next you have to take n is equal to 3q plus 1. For this also you have to prove like this, 3 conditions you have to check. For n plus 2, n plus 4. In first case, n value is 3q. In second case, you have to take n is equal to 3q plus 1 and add 2 and add 4 and check out whether which one is divisible by 3. This case 1 is over, comes to case 2. So there are 3 conditions. Just now we have proved n is equal to 3q. Now take case 2, n is equal to 3q plus 1. So come on, tell me whether it is divisible by 3. No. Why? Here the plus 1 means the remainder is 1. It is not divisible by 3. What is the next condition? N plus 2 means you have to add 2 to the n value. N value is what? 3q plus 1 and plus 2. It becomes 3q plus 3. Take 3 common, 3 into q plus 1. So clearly it is 3 multiple. So it is divisible by 3. Okay. Now find n plus 4 value. N plus 4 means n value is 3q plus 1 and plus 4 means plus 4. So now this is equals to 3q plus 5. So 3q, write 5 as 3 plus 2. Take 3 common in these two terms. So again 3 into q plus 1 plus 2. So here what is the remainder? So 3 into q plus 1 plus 2. So this plus 2 is the remainder. So it is not divisible by 3. Look at here. Case 2, n value is actually 3q plus 1. So n is not divisible by 3. N plus 4 is not divisible by 3. The only one out of all these three, here n plus 2 is divisible by 3. In previous case, n is equal to 3q is divisible by 3. In this case 2, n plus 2 is equals to, we get 3 into q plus 1, so it is divisible by 3. That means out of all these three situations, the only one will be divisible by 3. So think what is case 3? Yes, now assume n equal to 3q plus 1. You have to check for n, n plus 2, n plus 4, whether it is divisible by 3 or not. Okay, move to case 3. So they are the possible n values. Now case 3 means n equal to 3q plus 2. Okay, obviously if plus 2 is remainder, so it is not divisible by 3. Okay, are you getting? Now, what is second one? N plus 2. Find n plus 2 value. So here n value is 3q plus 2. Add 2 to this one. That becomes 3q plus 4. I am writing 4 as 3 plus 1 and take 3 common in these two. You will get 3 into q plus 1 plus 1. So we know very well remainder is 1. So it is also not divisible by 3. N is not divisible by 3. N plus 2 is not divisible by 3. So you have to find one more, that is n plus 4. What is n value? 3q plus 2. Plus 4 means we are adding. Now it becomes 3q plus 6. Take 3 common in these two. You will get 3 into q plus 2 plus 0 is the remainder. So remainder 0 means it is divisible by 3. Understood? So in case 3, n plus 2 is not divisible by 3 and the only one n plus 4 is divisible by 3. So in this way you have to prove this sum. Look at here finally. So one and only one out of n or n plus 2 or n plus 4 is divisible by 3. Once again, so one and only one out of n plus 2, n plus 4. So in case 1, n is divisible by 3. In case 2, n plus 2 is divisible by 3. And in case 3, so n plus 4 is divisible by 3. Means out of all the 3, they are n plus 2, n plus 4. The only one is divisible by 3. So in this way, you have to prove or you have to solve this sum. Okay. Now, remind one thing once. What is division algorithm? Given positive integers a and b, there exist unique pair of integers q and r satisfying a is equals bq plus r. Here r is 0 less than or equal to r less than b. It is division algorithm. So we have discussed on last class. So here if r is equals to 0, then what happens? See there, a is equals to bq plus put r equal to 0. Now it becomes a is equals to bq. means A is equal to BQ means B divides A, and B is a factor of A. So A is equal to B into Q means B divides A, and one more, B is a factor of A, and as well as Q divides A and Q is a factor of A. So all we know. And what A? A is multiple of both B and Q. For example, let us assume 12 is equals to 3 into 4. So 3 and 4 are factors to A, and 12 is a multiple of 3 and 4. In the same way, A is equal to BQ implies B divides A, B is a factor of A. In the same way, Q divides A and Q is a factor of A. And A is multiple of both B and Q. Okay, basing on this, we will discuss next topic. So important concept of factors of numbers. So let us see one concept regarding factors of numbers. Before that, just simply remind one thing. What is prime number? What is the definition of prime number? Yes, tell me. If a number has only two factors, then it is called as a prime number. If a number has only two factors, then it is called as a prime number. What are the two factors? One and itself. One and itself. If a number has one and itself are as factors, that is called as prime number. Okay. Give few examples. Yes. 2, 3, 5, 7, 11, and so on. These are the prime numbers. Okay. So, what is composite number? What is composite number? Means, if a number has more than two factors, then it is called as a composite number. If a number has more than two factors, then it is called as a composite number. Okay. If a number has only two factors, that is a prime number. If a number has more than two factors, that is called as a composite number. So here we have the examples: 4, 6, 8, 9, 10, 12, 14, 15, etc. Observe one thing. Where is 1? It is neither prime nor composite. Then what is 1? Think and think. I will tell. Then after. So look at a few examples. First one, we know 24 is a composite number. Okay. We know about 24, it is a composite number. So we will write the prime factors of 24. So just we will write the prime factorization of 24. So I am taking one pair. Initially I am taking one pair of factors, that is 2 into 12. 2 into 12. These two are the factors of 24. So I am taking 2 into 24. Sorry, 2 into 12. So again 12 can be written as 2 into 6. Because 12 is not a prime number. So in the prime factorization only you have to you can see only primes. So 2 into 12, and 12 can be written as 2 into 6. Again 6 is not a prime number. So write it as 2 into 3. Finally, all these are primes. 2 into 2 into 2 into 3. So prime factorization of 24 is 2 into 2 into 2 into 3. Okay. Look at one more. So I am writing 24 factors as 4 into 6. It is also one more pair of factors of 24. Okay. 4 into 6. Now, we know 4 and 6 are not prime. So write 4 as 2 into 2 and 6 as 2 into 3. Look at here. Again 2 into 2 into 2 into 3. Same as this one. Okay. Next, one more pair. I am writing 24 as 3 into 8. So 3 is a prime number and 8 is not a prime number. So I am writing again 3 into 8 is equals to 2 into 4. Okay. Again 4 is not a prime number. Write it as 3 into 2 into 2 into 2. Okay. Observe all these three situations. So irrespective of order, the prime factors are same in all the three situations. Okay. Irrespective of order. So in these three conditions, in three situations, prime factors are same. Okay. Look at the prime factorization of 18. So I'm taking one pair 2 into 9 and 9 is not a prime number, so write 9 as 3 into 3. So 18 is equals 2 into 3 into 3. These are the prime factors of 18. Now I am writing as 3 into 6. I am taking one more pair of factors of 18, that is 3 into 6. So 6 is not a prime number, so write it as 3 into 2 into 3. Okay, here also observe these two situations. So order is different even though the prime factors are same. Okay, it is a composite number. So irrespective of order, the prime factors are same. So now look at these. So just now we have written the prime factorization of 24. So 2 into 2 into 2 into 3 and 3 into 2 into 2 into 2. It is same as this one. And 18 is equals 2 into 3 into 3, 3 into 2 into 3. If you take 20, 2 into 2 into 5, 5 into 2 into 2. Okay. So what we observe from this, every composite number can be expressed as product of primes and the factorization is unique apart from the order in which the prime factors occur. So observe these three examples. Every composite number can be expressed as a product of primes and the factorization is unique. Okay. So apart from the order in which the prime factors occurs. So in whatever the way you write, so always the prime factorization of every composite number is unique irrespective of order. So this is known as fundamental theorem of arithmetic. So this every composite number can be expressed as product of primes and the factorization is unique apart from the order in which the prime factors occurs. This is called as fundamental theorem of arithmetic. Now tell me again, fundamental theorem of arithmetic. Okay. Now the statement of fundamental theorem of arithmetic is every composite number can be expressed as product of primes and the factorization is unique apart from the order in which the prime factors occur. So this is the statement of fundamental theorem of arithmetic. Okay. So all this in your textbook. So after completion of every class, you have to do the example sums and sums in the exercise. And if you have any doubt, ask your teachers, math teachers. They are ready to clarify your doubts. Okay. Now look at exercise 1.2. Here few sums are there. We will solve this one. Look at first bit. Express each of the following numbers as a product of its prime factors. Express each of the following numbers as a product of its prime factors. Okay, now write 140, 156, 3825, 5005, 7429 as product of primes. So I will tell few sums. Look at first one. Express 140 as product of its prime factors. Okay. So first of all, do like this. 2 7 ja 2 0. Okay. 70 is not a prime number. Again, divided with 2. 2 3 ja 6. 1 is the remainder. 2 5 ja 10. So 35 is not a prime number. So it can't divisible with 2 and 3. So divide with 3. 5 7 ja 35. Okay. So the prime factorization of 140 is 2 into 2 into 5 into 7. So first step 2 into 70. 70 again we can write as 2 into 35. 35 is not a prime number. So write it as this one. 2 into 2 into 5 into 7. It is the prime factorization of 140. You have to solve this. These questions come for in part B or for 1 mark. Next, we will solve the fourth sum. Express 5005 as product of its prime factors. Okay, 5005. So do like this. 5 1 ja 5, 0 0, 5 1 ja 5. So 5005 divisible with 5. Now 1001. So it can't divisible with 2, 3, 5. So try next prime number, that is 7 with 7. 7 1 ja 7, 3 remainder 30, 7 4 ja 28, 2 remainder 21, 7 3 ja 21. Okay, now this 143 can't divisible with 2, 3, 5, 7. So what is the next prime? 11. Try with that one. 11 1 ja 11, 3 is the remainder 33. 11 3 ja 33. So 5005 can be written as 5 into 7 into 11 into 13. It is the answer of this question. The first step, 5 into 1 not 1001. 1001 can be written as 7 into 143. And again 5 into 7 into 11 into 13. These are the prime factors of 5005. So remaining sums solve yourself. Okay. So basing on these two examples, few more sums are there in the exercise 1.2 first bit, first sum. So do the remaining. Now, so finding HCF and LCM of two numbers using this prime factorization method. So we can find HCF and LCM of two numbers using prime factorization method. So first of all, how to find HCF and LCM with the prime factorization method, just let us see. So how to find HCF? Now tell me what HCF? Yes, highest common factor. Okay, how to find using prime factorization method. So yesterday we find with the help of division algorithm, and in 6th or 7th class by using division method. So we did and we found HCF. So now you have to find HCF as well as LCM using prime factorization method. Let us see how to find HCF. Okay, product of smallest powers of each common prime factor of the numbers. So this is a way to find HCF. So first of all, I have to write the prime factorization of given 2 or 3 numbers. In that, smallest powers of each common prime factor of the numbers. So if you do so, you are able to find HCF. So we will see with few examples. Now, how to find LCM? Okay, we know very well what is LCM. Yes, least common multiple. Now, how to find LCM? So, product of the greatest power of each prime factor of the numbers. Product of the greatest power of each prime factor of the numbers. Here in case of HCF, we are taking the common prime factors, smallest powers of each common prime factor. But in case of LCM, it's only we multiply the greatest power of each prime factor, not common prime factor, each prime factor. Okay, product of the greatest power of each prime factor of the numbers. So this is the way to find LCM. Okay, so using factorization method, prime factorization method, so we are able to find HCF and LCM. Okay, so I explain with the help of an example. Okay, look at example number 4 in your textbook. Example number 4. The question is, find the HCF and LCM of 12 and 18. HCF and LCM of 12 and 18 by the prime factorization method. So in the examination, he mentioned the method in which method you have to follow to find HCF and LCM. Okay, so you have to find HCF and LCM using prime factorization method. Okay, what is the first step? Yes, first step is write the prime factors of 12 and 18. So we know 2 into 6 and 2 into 3. So 12 is equals 2 into 2 into 3. What about 18? 2 into 9, 18. Again 3 into 3, 9. That means 18 can be written as 2 into 3 into 3. And 12 can be written as 2 into 2 into 3. Okay. Now, writing same as here. Look at here. 12 is equals to 2 square into 3 to the power of 1. Okay, 2 into 6, 2 into 2 into 3. So this is 2 to the power of 2, this is 3 to the power of 1. And in case of 18, 2 into 9 and again 2 into 3 into 3. Okay, 9 is equal to 9, we are writing as 3 into 3. So it becomes 2 to the power of 1 and 3 to the power of 2. So the first step is over. What is that? You have to express 12 and 18 as the product of primes. Now, just now we have discussed how to find HCF. Product of smallest powers of each common prime factor of the numbers. So here, look at here, HCF of 12 and 18 is equals to, out of all these, so 2 is a common factor. Here is there, here is there. So in these two, which one is smaller? Yes, 2 to the power of 1. Here 3 to the power of 1, 3 to the power of 2. So it is 3 is common prime factor. But which one is smaller? 3 to the power of 1. Take here. So multiply these two. Okay. So 2 into 3, 6. The 6 is the HCF of given two numbers. Okay. After writing it's a prime factorization, you have to take the smallest power of each common prime factor. You have to take the smallest powers of each common prime factor. Okay. So finally HCF of these two numbers is 6. Now how to find LCM? Yes, product of the greatest power of each prime factor of the numbers. So here you have to look at the common factors here. So no need of looking at common factors. What are the prime factors there? So in that you have to take the greatest power of each prime factor. Now let us see. So 2 power 2 is there, 2 power 1 is there. So in which one is greater? Yes, 2 power 2. So in 3 power 1 and 3 power 2, which one is greater? 3 power 2. So 2 square equal to 4, 3 square is equal to 9. 36 is the LCM of these two numbers. Okay. So in this way, you have to find the LCM and HCF using prime factorization method. Generally, this question comes for 2 marks in the examination. So he don't give from the textbook. He may change the sum. So that is different from the textbook. So you need to know the process, the procedure, how to find or how to solve the problem. So basing on that, you have to solve few more sums. And as well as you can create new sums. That is one of the topic in format assessment. So there we will write the creative new problems. So basing on this, you have to create new sums and all as well as also solve. So this is a way to find HCF and LCM using prime factorization method. So we will solve one more sum. So this is homework for you, children. Find HCF and LCM using prime factorization method and do this topic. First question is 120 and 90. Second one is 50, 60, and third one is 37 and 49. Okay, this is homework for you. So in this, I solve one sum, that is LCM and HCF of 120 and 90. So first of all, what is the first step? You have to write the prime factorization of each number. So 120 is equals to 260, 230, 215, 3 5 ja. Means 120 is equals 2 into 2 into 2 into 3 into 5. Means 2 to the power of 3, 3 to the power of 1 and 5 to the power of 1. And again, the prime factorization of 90 is 2 4 ja 8, 1 is the remainder, 2 5 ja 10. So 3 15 ja, 3 1 ja 3, 1 is remainder, 3 5 ja 15. So 3 5 ja 15. So 90 can be written as 2 into 3 into 3 into 5. Okay. In this way, first of all, you have to write now 120 is equals to 2 cube, 3 to the power of 1, 5 to the power of 1. And 90 is equals to 2 to the power of 1, 3 to the power of 2, 5 to the power of 1. So already we learn how to find HCF, the smallest powers of each common prime factor. Okay. Look at here. Out of 2 to the power of 1, 2 to the power of 3, which one is smaller? 2 to the power of 1. In these two, 3 to the power of 1. In these two, they are common. So take ones, 5 to the power of 1. So multiply all these three, you will get 30. 30 is the HCF of this 120 and 90. Next, so to find LCM, take the greatest power of each prime factor of the numbers. Okay. Now, LCM of 120 and 90 is, look at once again, 2 to the power of 1, 2 to the power of 2 cube.
ఓకే సార్ అశోక్ సార్ ఏంటి లైన్లో అయిపోయిందా
మధ్యలో బ్రేక్ అయింది సార్.
ఓకే సార్ కాల్ చేస్తేనా
జాయిన్ అయ్యండి. అశోక్ సార్ అన్మ్యూట్ చేసుకోండి, మ్యూట్ లో ఉన్నారు. సార్ అన్మ్యూట్ చేయండి సార్ అశోక్ సార్.
Okay, sir. So this is a way to LCM and HCF of 120 and 90. So in exercise 1.2, so in second sum, look at this first bit. Here he has given three numbers. Find HCF and LCM of 12, 15, 21 by the prime factorization method. So you may find the HCF and LCM of two numbers or three numbers or any numbers. So the process is same. So first step is, so you have to write the prime factors of 12. So 2 into 6, again 2 into 2 into 3. So finally 12 is equals 2 square into 3 to the power of 1. So next 15. So 3 into 5. So both are primes. So its prime factorization is 3 to the power of 1 and 5 to the power of 1. Now 21 is equals to 3 into 7. So these two are primes. So 3 to the power of 1 and 7 to the power of 1. So first step is over. So now find the HCF. So what is HCF? How to find? Product of smallest powers of common prime factorization. Look at here. In all the three numbers, prime factorization of three numbers, 3 to the power of 1 is only the common factor in all the three numbers. So HCF is take 3 to the power of 1. Okay. Now, in case of LCM, look at here. 2 square is there in the factorization of 12, but it is not there in these two. Even though, so what is LCM? Product of greatest powers of each prime factor. So 2 square is there. 2 square is there here. So take this one. So 3 to the power of 1 is there in three numbers. So take 1 and 5 to the power of 1 and 7 to the power of 1. So here the confusion is, in case of HCF, we will take the smallest powers of each common prime factor. Remember one thing, common prime factor. But in case of LCM, don't look at the common prime factor. Any factor, we take only the greatest power. So 2 square, in case of 3, 2 to the power of 1. In case of 5, only 5 is there. So take 5 to the power of 1. So in case of 7, only 7 is there, 7 to the power of 1. So if you multiply all these, you will get 420 is the LCM of these three numbers. So practice remaining sums. So with this, I conclude my class, today's class. Thank you, sir.
Thank you. Thank you very much, sir. Screen share. Thank you very much, Ashok sir. You have given an excellent explanation about the exercise 1.1 and the remaining sums. So see you tomorrow on TCEB Suryapeta YouTube channel at 9 o'clock. Thank you for the technical team who is supporting, extending their services from the last 8 months onwards. Thank you very much. See you tomorrow at 9 o'clock.